This example is one of my favorite examples because it's real and it's one that I experienced when I was attending UCLA. When taking multiple choice tests, it's imperative that the grading scale discourages guessing. Um, as a professor, we actually want to know if students know the concept versus just getting lucky guessing, right? The This is a really important question. So to do this, one professor created a scale that looked like this. When you get a correct answer, so on your multiple choice test you get it right, you get 3 points. If you get it wrong, you lose 4 points from your test. So yes, it actually was possible to have negative scores. And then finally, a blank response just got you a point. So if you don't know, you get a point for just leaving it blank and admitting I don't know. All right. So now, using this grading scale, if there were five choices to choose from, so meaning there was like A, B, C, D, and E, like a Scantron test, and you had to choose one of them, um, would it be in the best interest of a student to guess, or would it be better for them to leave it blank? So how we're going to calculate this, well, clearly this is coming in the expected value section. So see if you can figure it out. Pause the video, give it a shot. You have all the skills you need. And then I'll come back and walk you through it. Okay, so we're going to need to create a probability distribution table. And we're going to have to think about um, the different possible outcomes. Now, the outcomes are either I could get a wrong answer or a right answer, right? Now, that is if I'm guessing. The assumption is making assumption I'm guessing. So if I get it right, I'm going to get 3 points. If I get it wrong, I'm going to lose 4 points. Now, if I can't eliminate any, so that means I'm literally just guessing out of all five. I've got no narrowing it down. That means there's a 1 out of 5 chance I'll get it right and a 4 out of 5 chance I'll get it wrong. So therefore, the expected value would be what? Well, as we saw in the previous problems, take the value, which is the value of 3 times 1/5, plus, now take my other value, which is a -4 times 4/5, and those, when I add them together, would result in, I don't know, I gotta pause the video and do it. Actually, what am I saying? I don't need to do this. This is math we could do, right? We're smart college students. 3 times 1/5 is 3/5. And then 4 times 4 is 16/5. So therefore, that is going to result in a negative. Well, 3 take away 16, that's a negative 13/5. And to change that, if I wanted to dividing by 10, I multiply both the numerator and denominator. So that would be 26/10, multiply both by 2. So therefore, the fraction falls out pretty simply now, which would just be a negative 2.6. So think about what that means. The expected value was negative 2.6. The units on this are the same as the values from our table. That was points. So what this means is I expect to lose 2.6 points per guess. Do I want to guess? Well, no. If my average is going to be a negative 2.6 and I get 1 point for leaving it blank, I'm leaving it blank. I'm not guessing. All right, well, but now that we all hopefully will sit down to a test and we don't look at all the problems and be like, I got no idea. It could be any of them, right? Usually, hopefully, we can eliminate one, right? So in that case, how does that change the problem? Still the same grading scale, still 3 points for getting it right, 4 points for getting it wrong. Okay, lose 4 points for getting it wrong. But it's no longer out of 5 choices because there's only 4 choices left because I eliminated one. And there's still, out of those 4 choices, there's still one that'll get me a correct answer, but there are now only 3 that'll get me a wrong answer. So how does that affect this problem? Well, it's still 3 times 1/4 for getting it right. One out of 4 times I'll get it right, and then a -4 times 3/4 because I will get it wrong 3/4 of the time. And what does that result in? All right, well, let's see. The expected value would be 3/4 minus 12/4. You can clearly see it's still going to be negative. 3 take away 12, so what is that? Negative 9/4. And so that is a negative 2.25. It's better. Now I'm only losing 2.25 points per guess. But do I want to guess? No, guessing would be bad. Okay, so now try, if you haven't already been doing this, pause the video, try to do the next one on your own, all right? Here, we are now going to eliminate, what if you could eliminate two of the options, right? Two of the potential distractors. All right, give the problem a try. Okay, here we go. So 3, -4. And let's see, now again, now there's only, if I'm eliminating 2 out of the 5, there's only 3 left. So therefore 1 out of 3 is right, 2 out of 3 is wrong. So therefore my expected value would be 3 times 1/3 minus, well, plus a -4 times 2/3. And does this finally get us to the point where guessing makes sense? Well, 3 times 1/3 is 1. Actually, I'll keep common denominators. 3/3 minus 8/3. Nope. So we're still at -5/3, which means I'm still have a negative expected value, right? And for as a decimal, this is -1.6-ish, 1.6 repeating. So what does that mean? Well, that means I still don't want to guess because I'm losing 1.6 points per guess on average, and I get 1 positive point for leaving it blank. All right, right. So surely if I can eliminate everything and I'm down to a 50-50, right? And then another way I could have phrased this problem is just give you the original problem and just say to you, how many choices would a student need to eliminate it to make guessing in their favor? And what I do is I just change on your test problems or quiz problems. I just change these values. Instead of getting 1 point for leaving it blank, maybe you lose 1 point for leaving it blank. And then that still hasn't changed our decision process, because losing 1 point is better than losing 2.6. Losing 1 point is better than losing 2.25. Losing 1 point is still better than losing 1.6. And so you have to go through this process yourself and figure out, when is that tipping point? When is it better? And so we're down to only 1 left, right? Because now if we can eliminate 3 possibilities, right? So if there is an A, B, C, D, and E, and you're able to eliminate 3 of them, we are now down to a 50-50, right? We are down to, it's one of the two. So half the time I'll get it right, half the time I'll get it wrong. And if you're good with your numbers and kind of already seen what's happening, half the time I'm going to get 3 points, and half the time I'm going to lose 4 points. Well, you can already logically say you're going to lose more than you're going to win. So, but anyway, this is 3 halves minus 4 halves, which gives us a -1/2. So therefore, when do you guess? You don't, right? Only when you know the answer do you actually answer it. And I could have easily made this 0 points. I just made it the 1 point just to really illustrate that what we're doing is comparing the guessing compared to the value of leaving it blank and deciding which is better. Okay, so at this point we have finished the lesson on expected values. So I hope it all went well, and I will see you in the next video.